All right, let's jump right in. What if I told you there's a single substance, a simple material, that could help us tackle some of the biggest challenges on the planet? I know, it sounds like something straight out of a sci-fi movie, but what's wild is that its roots are actually in ancient practices. So, yeah, it's a huge question, right? But that's exactly what we're digging into today. Because this material, it's real. It's called biochar, and honestly, its versatility is just, well, it's pretty mind-blowing. Okay, so what is this stuff? At its core, you can think of it as a kind of supercharged, engineered charcoal. You basically take organic waste, things like wood chips, leftover crops, even manure, and you cook it at a high temperature without much oxygen. That process is called pyrolysis, and what you get at the end is this really stable, super porous, carbon-packed material. So where do we even begin with all its uses? Well, let's start with probably its most famous application, one that's literally right under our feet: agriculture. Farmers and soil scientists actually have a nickname for it. They call it black gold. And that's not just some catchy marketing term. No, it really gets at the incredible value this stuff brings to the soil. So, how does this black gold actually work its magic? Well, for starters, it's kind of like a luxury hotel for nutrients. It holds on to them, keeps them from just washing away. Its porous structure is also amazing for soil. It opens up all these little pathways for air and water, which lets plant roots breathe and grow. And on top of all that, it can help neutralize acidic soils, making the whole environment way healthier for crops. And check this out, because this is one of its biggest benefits, especially with our changing climate. Some studies have shown that adding biochar can boost a soil's water-holding capacity by up to 370%. Just think about that. For places struggling with drought, that's not just helpful, that is an absolute game changer. Okay, so it's amazing for farms. But biochar's job doesn't stop there. Not even close. It also doubles as the planet's very own cleanup crew. It's a powerhouse for environmental remediation. The secret here is all in its physical structure. Biochar is just riddled with tiny pores, which gives it a crazy amount of internal surface area. This makes it a perfect adsorbent. You can just think of it like a super advanced sponge that's designed to grab onto and trap all sorts of nasty stuff. And the list of what this sponge can clean up, it's seriously impressive. We're talking about locking down toxic heavy metals like lead and mercury in contaminated soil. It can pull pesticides and industrial dyes right out of wastewater. There are even specialized magnetic versions of biochar that can be used to clean up oil spills, which makes that whole process way more efficient. And here's where it gets really clever. It creates this amazing sustainable cycle. So the biochar pulls all this excess nitrogen and phosphorus out of the water, right? That stops those harmful algal blooms that are so bad for our rivers and lakes. But here's the kicker. That nutrient-soaked biochar isn't waste. It becomes this incredible slow-release fertilizer. So you're closing the loop, putting those valuable nutrients right back where they belong. This amazing cleanup ability naturally leads us to its role in fighting what is, maybe the biggest environmental challenge we face. So, biochar comes at climate change from a few different angles. First, and this is the big one, is carbon sequestration. When you turn biomass that would just rot into stable biochar, you're locking that carbon away in the soil for centuries, maybe even millennia. Second, it helps cut down on other potent greenhouse gases coming from the soil. And third, you can even use it to capture CO2 emissions right from the source, like an industrial smokestack.
And the numbers here are just wow. For instance, just by mixing biochar into your compost, you can cut ammonia emissions, which lead to nitrous oxide, by as much as 98%. That's a huge impact from a pretty simple step.
Okay, so we've got farms, we've got environmental cleanup. Pretty impressive, right? But hold on, because this is where the story takes a really unexpected turn. Biochar is now moving out of the field and straight into the high-tech lab. Let's start with energy storage. Because of that huge surface area we talked about, plus its ability to conduct electricity, people are now developing biochar as a cheap, sustainable material for electrodes, specifically for supercapacitors. Those are the things you need for devices that have to charge and discharge super fast.
And it doesn't stop there. It's also popping up in clean energy. Turns out biochar can be used as a catalyst to help split water into hydrogen and oxygen. That process, electrolysis, is a really big deal if we want to build a green hydrogen economy.
Even the buildings we live and work in can get a biochar upgrade. Get this. By replacing just a little bit of the cement in concrete with biochar, you can actually lower the huge carbon footprint of construction. And, as a bonus, it can even improve the building's insulation. And think about advanced materials like bioplastics. Well, if you add some biochar into the mix, it makes them stronger and last longer. It can even make them antimicrobial, which is a massive plus for something like, say, food packaging. And for the final and maybe the most surprising one of all, you might actually find biochar in your bathroom cabinet. Yeah, really. That same amazing ability to absorb stuff makes it perfect for cosmetic cleansers and face masks that are designed to pull oil and dirt right out of your skin.
Okay, so let's just take a breath and step back for a second. We've gone from our farms to our faces. What's the big picture here? What we've found is a genuine multi-tool for a more sustainable planet. I mean, it's working in agriculture, cleaning the environment, powering our future, and changing industry. That whole Swiss Army knife thing we started with, it's not just a catchy title. It perfectly describes how this one single material can help us tackle a whole range of problems.
And for me, this is the most exciting part. Biochar is this amazing blend of the ancient and the futuristic. It's a technology that literally connects our past with our future. So the real question isn't just what else can it do? The bigger question is, what should we do with it next? With a tool this powerful, where should we aim it to make the biggest difference?